Okay, now that we kind of went over those problematic areas, let's do the whole thing. Okay, solve each equation. This is just equations, equals, you don't need number lines. Put a 1, so 2 times 1x is 2x plus 8 equals 8. Remember guys, x is on one side, constants on the other. So I've already got the x on this side. Move the 8 over to the other side. 8 minus 8 is 0. Divide by 2, and the solution is 0. You can get a solution of 0, okay? No, it's not all solution, no solution. It's all solutions, no solution when the x's are canceled, which are not. Okay, get the letter terms on one side, so it's minus 3w. That's your first step. That's what you should always be thinking. Get the constant terms on the other side. 4w equals 92. Divide by 4. I think it's 23. Yeah, it is. Okay. Okay, next one, same idea. So negative 3x plus negative 12 plus the 2 afterwards equals 8. Do not distribute the negative 3 to the 2, okay? So you make sure your variables are on one side. We already have that. Now we move our constants to the other side. Let's combine these first. Negative 2 plus 12 plus 2 is negative 10. Now you can move negative 10 to that side by adding it. So plus 10 plus 10. So negative 3 times x equals 18. Divide by negative 3. And x equals negative 6. Okay, your parentheses is here. Make sure you got a plus though. If you just make it plus and then whatever after it negative. Alright, now the multiplier is a negative 4, so we're distributing the negative 4. Over here you just got the 19x plus 20. So I drop the plus. What's negative 4 times 3? Negative 12. What's negative 4 times negative 4? Positive 16x. Now we also have an x we need to add, and it has a 1 coefficient. Now, you got 3 x's. They all need to be on one side. So what we do first is combine the two that are on the same side. So that's 17x plus negative, I'll just go over here. 17x plus the negative 12 and then 19x plus 20. Now, get the x's on one side. It doesn't really matter which one you move, okay? Let's move the 17. It's smaller. I kind of like to move the smaller one, but it doesn't really matter, okay? 2x plus 20. Now, once that's done, and we have our x set, we move our constant to the other side, so minus 20. We're not trying to get equal to 0 on any of these, so if you're doing that, knock it off. You do those on x when you got an a, and you do those on quadratic equations. These are all linear equations. There's just one solution. And divide by 2, and you get negative 16. Okay, number 5, plus negative 4 times, and over here you already got the plus, so 6 times. So over here you take 4 times 1x and 4 times negative 3, so that's going to be 4x plus negative 12, but you still have to add the 20. 6x plus 18. Remember, let's get all the x's to one side and all the constants on the other side, okay? So I have these two x's right there, okay? Get them on one side, I'll minus the 4x. You could also do the 6x, it doesn't really matter. So you got negative 12 plus 20, and then 2x plus 18. Now all the non-x numbers have to be on one side. Well, there's 3 of them, so we're going to combine these two. That makes 8. And then get the 18 on the side of with the 8. Remember, you should end up with x on one side and the constant on the other. So you got 2 times x. 8 minus 18 is negative 10. Then I can divide at the end. So x, negative 5. Okay, number 6, 11 plus 3x minus 7 equals 6x plus 5 minus 3x, okay? First off, let's get all the x's to the same side. Well, there's 3 of them, so we're going to combine the 2 there. 6 plus negative 3 is 3x plus the 5. 3x, and then 11 plus 3x minus 7. Well, now you have x's on opposite side, but they're the same, okay? When they are the same, you need to stop and cross them out. And then this becomes all solution or no solution. Here's what I don't want to see, and I saw this a lot. We'd minus a 3x, and then for some inexplicable reason, you'd put x on the other side. No, they're just gone. Okay, they vanish. So which one is it? Well, that's 5, and we're going to combine those because they're on the same side. That's 4. Well, 4 and 5 aren't equal. That's a no solution. Okay. Okay, now over here. Holy cow, we got a lot of x's. So first, let's clear our head, get rid of our parentheses. Okay, so 3 to 1x, 3 to negative 4, so it's going to be 3x and negative 12. Then we have to add the 2x. Over here, that's going to be 2 times 2x is 4x, and then 2 times negative 6 is negative 12, plus the x, which would have a 1. Let's get all the x's on one side. Well, first we have to combine the 2 that are on the same side, okay? So it's going to be 5x plus negative 12 on that side, and then 5x plus negative 12 on that side. Now, the x's are on opposite sides, but rather than get them together, they're the same, so they're going to cancel out, okay? And then that's all solution or no solution. Okay, negative 12, negative 12, okay? That's all solution, okay? Because they're the same. Here's another thing you could do if that is confusing to you. Remember what I said, you're trying to get the x's all to one side. So if you minus 5x and you minus 5x, that's going to be 0x, okay? Well, if you have 0x, 0 times anything is 0, so that goes away. Even though I don't know the x value, I know that's 0, and that's all solution. So if you by chance do subtract, that's fine, but you need to write 0x, not x, okay? 0x takes it out. Okay, now absolute value equations. Now remember, I just kind of showed how to clear your head on that. So you know right away you need to make a table. And you write the inside expression on each side of the table. Now replace the entire absolute value function with a d variable. I picked d because d stands for distance from 0. Now d's by itself, so we know exactly what the d is equal to. So on one side it's 5x plus 2, and on the other side we switch both the 5x and the 2 to their opposites, so negative 5x plus negative 2. So get your x's on one side, so minus 3x. Doesn't matter which side. 2x plus 2. Now get your constants to the other side. Minus 2, minus 2. 3 would equal 2x. Then divide by the x coefficient. That would be 1.5. Okay, now we're going to get the x's to one side. I'm going to get them over here. It doesn't matter what side you get them to. Doesn't matter. So 8x plus 5 equals negative 2. Get your constants to the other side. Okay, so that's going to be negative 7. And you can leave that as a fraction. I don't care. The decimal does terminate. Anything over 8 terminates. You can put that negative 0.875, or you can leave it in fraction. Doesn't matter. Now, you got to do the extraneous solution check. The D cannot equal a negative. You can't have a negative distance. 1.5, then below it, we're plugging them in separately, but I like to organize it like that so I don't forget. 5 times 1.5 plus 2, that's a positive, so that stays. 5 times negative 0.875 plus 2, that's a negative. See ya. Okay? D cannot equal a negative number. That's what check for extraneous solutions means. Okay, now inequalities. Same thing as an equation, you have to graph, and you also have to watch out for the sign switch. And this is my only, it's a single inequality, so I don't need a table. Okay, so the operations, you got negative 18 plus negative 5 times x. Now you want to highlight the times when you solve these, because if that's a negative, that sign has to switch. Now before I divide both sides by the negative 5, I need to take out the negative 18, and I don't switch the sign while I do that, because that's just adding and subtracting. So negative 5 times x, and then 70, and then divide each side by the coefficient. So you got x, negative 14. So negative 14, it's eating the value, so that means the value's higher. Negative 14 is bigger than anything x could be, so we're headed that way. Label it. Okay, number 10. 4x plus 12 greater, less than or equal to 44. Well, we have a multiplication operation to x, but it's positive, so we will keep the sign the same, because I'll divide each side in the end, but it'll be by a positive. So take out your 12. Remember, when you're doing adding and subtracting, the sign never switches. Then divide by 4, you have x and 8. Circle fill it, and it's eating the value again, so again it's headed this way. So that means the value of 8 is bigger than anything x could be. Because remember, it always eats the larger value. Okay, now these are compound inequalities. 4x, because you see two of them in the same problem, and it's the same thing down here. They're just, the process is the same, they're just written differently. You need a table, and you need a number line. So on the table, you just split them up. On one side, you got 4x greater than 24. On the other side, you got negative 5x greater than 35. Wall. Okay, you have multiplication, but it's by a positive, so the sign will stay, and we don't have to add or subtract. We just go divide. X, 6. Now go solve the other side. You have multiplication again by a negative, so you need to switch the sign. Because when you divide each side by a negative number, the sign flips. Okay, plot those numbers. 6, negative 7. So here it eats the variable, so that's this way. So if it's going out that way, the negative 7 has to go out that way. Neither one's filled because they don't have the line. So you write or and then just copy the answers. Okay, number 12 is the same thing. Okay, you need a table and a number line. Okay, so here's what you put on. You put the less than on one side, you put the less than on the other side. So on one side, you put negative 6, and then you put 2x minus 4. On the other side, you're obviously going to put the 12 and then the 2x minus 4 again. Do the overlapping circles, because then you'll see that that goes on both sides. Okay? Okay, so you got times 2, so you do have a multiplying number. It's a positive, so we're keeping the sign the same. We do have to take out the minus 4, though, with a plus 4 before I divide. So negative 2, 2 times x. So divide by 2, negative 1x. Okay. Then you have a multiplying number, and that'll be a keep again. Keep the sign the same. Take out your minus 4, and that's 2 times x, 16. Then divide by 2, x, 8. So negative 1 and 8. Circle circle, circle. -1 eats the x, so this way, so then that one comes the other way to join it. So you have a minimum and a maximum. You put x down just one time, -1, 8, eat the 8, eat the x. Okay, it's another one we worked on just a moment ago. Absolute value, you need a table. Don't put it below. Put absolute value tables, put this side, because you might have to do some work below, okay? So I put the expression 2w plus 5. Now take out the absolute value function, replace it with d. It's going to have a 3 as a multiplier. It's going to have a -5 after it. It's going to have a greater than 16, okay? Well, now I don't know my d value, okay? I'm going to need to know that. So d has a multiplying number, but it's positive, so the sign will stay the same, okay? Now you do have to take out the -5, so +5 plus 5. 3d, 16 plus 5 is 21, divided by 3. 21 divided by 3 is 7, okay? So you now have your d value greater than 7, and then -7, flip it. Okay. Now you just solve each one separately. You're going to need that too. Okay, it has a multiplying number, but it's positive, so the sign stays the same. We take out the +5 with a -5, and that's 2. 2 times w. Then divide by 2. 2 divided by 2 is 1. Okay, your w is already there. It has a multiplying number of 2, so keep the sign the same. You have to take your +5 out of there. 2w, -7 minus 5 is -12. Divide by 2, -6. So 1 and -6 are the critical values. Okay, it's eating the variable on that on 1, so that's this way, so that means then that one's going out the other way. So or, it's either a maximum, minimum, or an or. This one's an or. Okay. Okay, story problems. Members of a car sharing program pay a fee of $50 per month plus $7.65 per hour they use a car. A member's bill was $149.45 last month. This is all within the same month, so this per month doesn't really matter. Okay, the per hour is very important though, because I'm solving for the hours. A member's bill was $149.45 last month. How many hours did the customer use the car last month? So, dollars and hours. Hours is X, dollars is Y. So the dollars per hour rate, and it is a linear function, is $7.65 times X. So on my XY table, I have dollars is indicative of Y, hours represents X. So since we have our rate of change, we go 0, 1, 2, okay, and then block it. So the starting amount's $50, and then the slope is 765. So you just add 765. So it's going to be 5765. Take a calculator here. Gets me to $65.30. Okay, and then the cost ends up at, the closing amount's $149.45. How many hours is that? That's what I need to find. So on my line, you started at 50, and the number you're adding is $7.65 times X. Okay. So you got 50 plus 7.65 times X equals Y, and of course Y is going to be equal in the equation to $149.45. That goes in for Y. Okay, you got plus and times. You take out the 50 with a minus. Okay, it's going to be, I can do it in my head, but to save time, 99.45. divide each side by the 7.65. Okay. So 13 hours. Okay, number 15. Membership for the Alpine rock climbing gym is a $125 sign-up fee plus $25 per month. Membership for Rocco's rock climbing gym costs $50 for sign-up plus $30 per month. After how many months will the memberships cost the same? So they're linear functions. There's going to be two of them within the same problem. Months is X, cost is Y. So the dollars per month rates are 25 and 30 respectively. So that would mean I would make two tables to see what's going on. So Y is dollars, X is months. 012 block, 012 block. Now the $25, they started at 125, that's the y-intercept. Then I add 25, that's 150, then 175. Now the $30, they started at 50, then I start adding 30. So that's 80 plus 30 is going to be 110. So the costs are not the same yet, okay? I don't need to put anything below the blocks. I just need to find out when they cost the same. When are these equal? Okay, so I make two lines out of the tables. So y starts at 125 and we're adding 25 times x. That's the y-intercept, that's the slope. And then 50, the y-intercept, and I'm adding 30 equals y. Now when you're finding when they're equals, you make one equation, don't make two, okay? You just combine them. You want to find out when the cost, the y's are equal. So when does 125 plus 25x, when's that equal to 50 plus 30x? Okay, so let's take out the, get the x's on one side. You can take out either one you want. It's going to be 5x. Now get the constants to the other side. So minus 50, minus 50. So the variable term is 5x. The constant is 75. So I divide by 5. I get 15. Now you can always check answers on this by taking 125 plus 25 times 15. 500. Now let's see if that's 500 if I put 15 in for x. Boom. Okay, number 16. A high school band has woodwinds, percussion, and brass. There are 8 percussion players and 40 woodwinds. 1/5 of the band is brass. How many brass players are there? Make a... Here, I'll organize it like this. This is the ratio. This is the actual. Rate actual. Now, what's it say about the 1/5? They're brass. So you write brass, not brass, and total. Guys, the ratio is really easy to fill out. You put 1, but 5 goes here. That's your total. That's what a fraction is. It's the parts at brass over the total. So 1 plus this has to equal 5. Last time I checked, it was 1 plus 4. That's 5. Okay? Now I have to solve for the brass players, so I'm going to put a question mark. I'm not going to know that. These actual amounts are for your non-brass. 8 plus 40. 8 plus 40 is 48. Okay? So 4 times what's 48? Well, let's take 48 divided by 4. That's 12. Then you take 1 times 12 and 5 times 12. That's 12, which is the answer. Then 5 times 12 is 60. Not that that really matters, but there's your rate. That's your actual amount.